I tell you what, everybody, I've already done the introduction once. It was absolutely amazing. But unfortunately, being the idiot I am, I forgot to hit the go live button. So shall we just get straight into it? I will now hand you over to the lovely Heidi, who will run you through the order of play for the evening, which she's already done once, in fairness. But you did such a good job, Heidi. Would you like to do it again?
I will. So first we'll let gentlemen introduce themselves to the audience, then we'll have 10 minutes of opening arguments each, after which we will have 10 minutes of rebuttals each, and then back and forth discussions in turns, 3 minutes each, and questions starting at 8:35 UK time, PM. And you can post questions to the community tab, and Creaky will keep an eye on the super chats, where you can also ask questions, and those will be prioritized.
Yeah, so as Heidi just said, I'm just sharing a link to the community post. So if you do have any questions for Catz or Chirag, you can post them there. We will be prioritizing super chats, obviously, because that's the fair way to do it. And I will. Who would like to introduce themselves first? Catz, Chirag, have you?
I'll let Catz go.
Yeah.
Oh, well, I'll be very quick, because I think, obviously most people on this channel know me, so I'll be very quick. All I'm going to say is that in my communications with Chirag, I've been really positive over this past week, and I think we're going to set hopefully a new bit of a trend tonight for a different type of flat Earth debate. There will be no screaming, shouting, childish behaviour, anything like that. I'm looking forward to something that's going to be quite fruitful, and I want to thank Chirag for the way he's conducted himself and bought into this over this week. So I'll pass you on to Chirag.
Yeah, thanks for having me, guys. I like this platform. I think the concept of it is much needed, for sure. If we are ever to get to a unique solution, which is what I'm going to kind of focus on in the first half of my talk. So, I appreciate you guys having me. I apologize if there's sort of a dull, low frequency noise in the background. They're doing some repairs, and I'm not able to get access to the common areas because of COVID and stuff. But if it gets distracting or people in the audience, just let me know. I'll just mute it briefly, but it's kind of intermittent. But thanks for having me, man. I look forward to it.
Okay, so I think because I'm an idiot and I wasted the first 5 minutes doing an introduction to nobody, I think we should just rip straight into it. So have you decided between yourselves, guys, who's going to kick off, or?
I'll let Chirag decide who's going to kick off. Since, he's playing away tonight. So you get to choose who goes first, mate.
Yeah, if you don't mind, I'll go first. I'll kind of set the tone. I hope that, it's what we...
Just tell me when you start, and I'll start the timer.
Okay, if you can pull up my PowerPoint as well.
Yeah.
I pretty much structured my 2 10-minute sections to match the slides. So
okay. The timer 10 minutes starts. 3, 2, 1, go.
Okay, so once my PowerPoint comes up, I'll just going to use this first 10 minutes to talk about modeling. Conspiracy Cats reached out to me, and the title, this is "Why is there no working flat Earth model?" And so, good question, great question, very, very important thing to have, to understand our physical reality. And so I first will define what a model is. And so that's what I'm going to use the first 10 minutes to do. And then the second 10 minutes, I'm going to get into more, other reasons why I'm a flat earther, and then present some qualitative points as well. And then we'll move to the Q&A. So if we can go to the next slide.
Okay.
So the first slide, this is basically, there might be a bit of a delay when I'm watching on the watch page, but this is my first 10-minute slot. If we can go to the next one.
Okay. Oh, yeah, is that for you?
Yeah. So why flat Earth? So I want people to just a quick sort of overview of like what brought me to this place, debating this position of the geometry of the Earth, is that there was a time in my life where I felt enslaved. I think a lot of us do in corporate America, the corporate world in general. And so naturally, my mind wanted to understand that reality, and that sort of led me down the conspiracy path. And so, Russian Vids and Eric Dubé were the first couple, I believe, that I really, studied and looked at and all that kind of stuff. Russian Vids was a little bit more important, possibly because he, cited the Bible more, and so. This is the kind of trajectory that got me to this point. And so the Bible now, being a Christian, having a Christian background, this was very, very appealing for me and interesting to know that it took a stance on the shape of the earth. And so the Bible does take a very, very clear stance on that. And so that would be probably the majority of the reason why I'm even interested in finding out what the truth is. And then it also takes a stance on our spiritual surroundings. And so for me personally, I started seeing these two things, manifest in life. And so that's the most important thing about modeling fundamentally, is that it's a way to characterize what's going on in real life and then put a mathematical underpinning to it. So I enjoy that aspect of it. So, this is not a Bible-based, support of flat earth, but this is just the explanation for what got me here. I guess I have a high level question, and maybe we'll discuss this at the end, is like, I see the flat earth truth, if it is indeed true, which I believe that it is, and more really every day. To me, this would be God communicating to us something that, he's planning to do, on a large scale. And so I guess I have a question for Catz that he can answer if he wants to at the end. What if it is flat? Is God existing and then the Bible being true and then the end times being plausible as corollaries? Are those reasonable steps that a person can take? I certainly have. If people are aware of my channel called The Mind of God, that's where I stand. But that's sort of the trajectory that got me here. So if we can go to the next one.
Okay.
I want to talk about a model. And so I'm going to use a very, very simplified walkthrough of a model. But I want people to understand these steps are never violated. When anybody tells me they have a model, then these are the things that I'm expecting, and then I will then be able to challenge certain things about the model and accept it as having predictive capabilities or not. But these are always the case. So this is why I called this section of the talk Agree to Agree. To me, there is no disagreement for this first 10-minute slot. These are absolute facts that I'm presenting. The second 10 minutes are very much in debate. But so just to start off with just a simple setup here, like a picture, we say a picture is worth 1,000 words. In this case, when we debate, the ball earth and flat earth, it's worth at least 1,000 variables. And so these are just a few that I came up with that would need to characterize what is being rendered by an optical device. And so position of the light source, atmospheric conditions, which nested within that would be many, many variables and highly nonlinear, statistical and time varying. Viewing distance, height, the color of the actual object that is in the distance, optical properties of the lens, observer height, and then Earth surface geometry. And so these are all variables. That's not exhaustive, but if one were to then want to model what is being registered on that camera, these are a minimum number of variables that will be needed. So we can go to the next slide. Keep this in mind. I'm going to use this image and modeling what is being registered to convey what a model is. So keep this in mind. We're already dealing with a very, very multivariable problem here. And so what is a digital image? Well, fundamentally, it's a matrix. It's a partitioning, and each of these cells has a number, and then that number will assign to some color in a scale. And so fundamentally, a digital image, all the best that it can be is a collection of numbers, and so this is what I'm going to start using to, granularize the image, and then we're going to try and model one of these cells. And so just keep that in mind, though, fundamentally, if you're dealing with any kind of image, that it is just a collection of numbers, and then the better range that those numbers can traverse, and will give you better resolution, quality of the image. So just keep that in mind. This is a nice feature of any image, too, if anybody's familiar with MATLAB and other softwares. You can do a lot of very, very interesting analysis on this. You can do Fourier transforms, you can do frequency analysis and all that. So just keep in mind, fundamentally, an image is a matrix. So if we can go to the next one.
Okay.
Okay, so just to reiterate, this is just putting into a picture what I just said. Just remember that each one of these cells, call them a pixel, each one of this the sampling of the world through the camera, there's a number in there. I just picked sort of, small numbers, just to, put an example in there, but that number will map to a particular shade. And so if we can go to the next one. What I'm going to do now is walk through modeling one of those cells. And so this is what people do. They make observations. This would be the beginning of an observation. This would be the starting point. And then if a person is then going to take the task of doing modeling, then they would begin this very process that I'm going to talk about. So just to use a term that Rumpus likes to use all the time, it kind of has double meaning, like a pixel or a pixel. Let's pick one of these cells and model that number. So let's pick that one. I just picked it arbitrarily, the number 5. A person who is interested in modeling would want to model how that 5 got there. How did that 5 get registered in that particular cell? And then the minimum amount of information it would need to know to understand where that 5 came from are the variables that I listed. And so again, that's definitely not exhaustive. And there's many, many variables underpinning the atmospheric conditions. And so, but just, for the sake of this explanation of what a model is, just know that we're going to focus on this one cell. And so our goal for a person who would undertake this to model that 5 is to use all those different variables and come up with a relationship that will allow me to use those variables to predict what that number is, and then if another image were to be taken, what that number would be in the next iteration. And so this is what a person would be able to do if they have modeled that cell correctly or well. So if we can go to the next one.
Great.
Okay, so the nice thing, again, this is not a linear relationship, obviously, like I just said, but I'm just using this to explain my point. Let's say that now we do have an established relationship between all these variables and that number 5. That
1 minute left.
Okay. If we can go to the next slide, I'll just kind of hurry through this. So now we have an equation. And so there's a fundamental concept in linear algebra where you need to have at least the number of equations as the number of unknowns. And so once you have a set of equations that govern the relationship of that cell, then you have a model. And so you can't just use one equation to find out what that 5 is because you have many, many unknowns. And so once we have a collection of equations, we could use the neighboring pixels, we can use other images and all that. Now we have a model. So if we can go to the next slide, I want people to understand that some of these variables can be known, fixed. They can be random variables like the atmospheric conditions, and some of them may be unknown, like that we're trying to solve for. And so once we have a system of equations, we now have a model. We have modeled those.
Time is up.
Okay.
Catz, do you want to?
Now, Catz, would you get?
Sorry, Heidi, go on.
Yeah, Catz, would you get to go? Ready?
Yeah, can we just start? I'm going to rattle through these slides pretty quickly. So can we just have number 1 up to go with? Is that okay?
Catz, 10 minutes starting. 3, 2, 1, go.
Okay, so my definition of a model, or the way I'm going to come at this, is slightly different to the mind of gods. Essentially, when the human civilization arrived on Earth, they could look up at the sky, try and make sense of what was around them, and they could have a million different ideas of what the Earth could be, okay? That it could have been any single shape whatsoever. They had a million models. And then as time went on and they made observations and they improved in their understanding, they eliminated models. So, for example, some people to start with may have thought that the sun and moon were the same thing. That could have been in their model, and they might have thought that the sun switched off at night and become the moon. But then we see the sun and the moon in the sky at the same time, and we realize that that's true, and we tick that one off. And the fact is that as time has gone on, there are no alternatives left. We have ruled everything out apart from the globe. And it is as simple as that. Everything, and flat earthers won't come forward with a model. Flat earthers won't present a model because they know that any model they can produce has absolutely no legs whatsoever. We can see on the screen at the minute some things that no flat earth model can predict at all. It took me 5 minutes to think of these: sunrises, sunsets, seasons, celestial poles, the moons of Jupiter, retrograde motions of planets, solar eclipse, lunar eclipse, tides, why the sky is red or blue, how we predict the weather, why we have volcanoes on plate boundaries, why we have volcanoes at all, why is it daytime on one part of the earth and nighttime on the other, why did the sun and moon not fall out the sky, why has nobody ever confessed, right? And any kind of attempt to try and explain one of these things contradicts another one, and it's not possible to create a flat Earth model, and that's why flat earthers now use the term globe deniers, because they know that if they even attempt to choose any kind of model, it's instantly and easily just ripped apart and destroyed. Now, meanwhile, back in sort of the real world, if we go on to slide number 2, in the real world, using the heliocentric model and the science that surrounds it, we're able to do all sorts of incredible things. We're able to predict the weather. And I'll just stick with that because I don't want to use up too much of my time. Let's just take weather prediction. The weather is predicted using satellite imagery and using our knowledge of Coriolis effects and weather systems, everything that's wrapped around a globe, and we predict the weather. Now, let's imagine that the Earth wasn't a globe. We still predict the weather. But the people predicting the weather think that they're predicting it using the model of a globe. And that can only mean one thing. That can only mean that the people in charge of this crazy conspiracy have figured out how to predict the weather on a flat Earth, right? So they've figured it out. And then somehow they've manipulated all the meteorologists around the world to think that the technology they're using and the numbers they're crunching are based on a globe model, when actually somehow this secret information has been infiltrated from some flat Earth genius who knows how to predict the weather on a flat Earth, and is somehow conning everybody into thinking they're using data from a globe Earth. And yet none of these, PhD scientists that are involved in meteorology have ever even sussed that something might be wrong. Same with flight paths. People who plan flight paths, to save money and make the most efficient routes, they plan those flight paths based on a globe. But if the Earth isn't a globe, then some genius has managed to work out how to plan a flight path on a flat Earth, right? But then fool all the independent airline companies all over the globe, right? And fool them by somehow making them think that when they independently plot their own flight paths, that they're plotting it on a globe, but actually they're not, because their equipment has been infiltrated somehow. And I could go on and on, but let's just talk about how models constantly support the globe Earth. Let's look at slide 3. Now, I know that the Mind of God has a history in seismology, so I'm really interested actually in what he's got to say about this. This is a graph of all the different seismological stations over the globe, and if I go to slide 4, I put that in there for a different argument I'm going to leave out now, so we'll skip from slide 4 to slide 6. Sorry. Now, what a flat Earth... Yes, slide 6. Okay.
Yeah.
So what a flat earther will tell you, and is correct in, is that if we have three seismological detectors that are detecting P waves and S waves, then locally those 3 detectors, they can detect the epicenter of an earthquake, and we can do that accurately. And on a local level, we can treat that like we are, like the Earth is flat. Okay, and that's a rebuttal I've had to when I've used arguments about P waves and S waves, etc. So let's take it a step further. Rather than just talk about at local level, let's skip to the next slide. And let's look at some publicly available geological data from the United States Geological Survey. And here, if we look, are we on slide 7? Yeah, there we go.
Yeah.
If we look in the top left-hand corner, there are 4 squares, right? And I'm looking at the second row in, second square down. Next to the number 2, there's a red dot in that place. That red dot in that place represents an earthquake, and the waves coming out from that represent the surface waves, which go all around the Earth. Now, we know how waves travel. If I can just skip on to the next slide, slide 8.
Yeah.
We know, and this is just a visual example of water waves, and how water waves travel. We know how waves travel. And we can use microphones and luminosity detectors, etc., to show that light and sound travels in this way as well. We know how waves travel. If I go back one to slide 7, if we look at the red lines on this map here, this is how the surface waves are propagating across the globe. And that seems a very, 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 very odd way to travel. Now, I am not saying that flat earthers use this particular map as their model for the flat Earth, right? Because if they did, this would be a very odd way for the seismic waves to travel. It wouldn't look. What I'm saying is there is no model that a flat earther can use to take the data from these global seismic stations that will make anything look like a sensible method of wave propagation. But if we skip on to size 9, and again, this is all publicly available data, if we skip on to slide 9 and we are plotting exactly the same data and we are testing it against a globe model, then what we see is exactly what we would expect to see. Exactly what we would expect to see. You know, seismology and geology are entire sciences. If I skip on to slide 10, right, there are papers here testing, and we're going back to that word model, testing different flat Earth models. This paper here, and I can email it to you, talks about how the propagation of seismic waves is tested against different models of the interior of the Earth, etc., and how the algorithms put together to determine what the internal structure of the Earth is. Now, if there were different possibilities, that will come up. Scientists aren't out there to lie and just make things up. We're here to use the data and draw conclusions. But the fact is, it just doesn't draw a conclusion about any other shape than the globe shape whatsoever. If we skip on to the next, in fact, we'll skip all that for a second. Can we go on to slide 15, please? Now, again, models. Yeah, slide 15, thanks.
Yeah.
So what other model will work on a flat Earth, but not on on a globe Earth, but not a flat Earth? Well, we talk about gravity and the way gravity behaves. This is a GRACE satellite, and the GRACE satellite has been in space mapping the gravitational anomalies of the Earth's gravitational field, which we can see on the next slide, please, slide 16. Now, I know flat earthers will say, well, we don't send satellites into space. This is all being made up. But if it's all being made up, then this data can't be used. It can't be used effectively if it's just made up. So if we go on to the next slide, this is a slide I got from Tony, who's been on my channel, a PhD geophysicist, and he looks at changes of the Antarctic ice mass. Now, these satellites in space that detect the changes in the ice mass as these glaciers melt, when he's sending his geologists to these places and they go to these places, what they see on the ground is exactly the same information as they get from the satellite, which is incredibly curious if satellites aren't real and they're not up there detecting these changes in gravity. As the ice melts, we can detect that from space. We go to the spots and we see exactly what we should see. However, let's move on a little bit more. If we go on to the next slide, the same satellites are not just used by geologists. Not just used by people studying the Arctic. These same satellites are used to look at underground water storage. All right, so this here, because that's obviously going to affect. Thank you. That's obviously going to affect the gravity in the sky as well. If I go on to the next slide, please, Creaky.
Yeah.
This data is useful, right? There are scientific paper after scientific paper, and you can cycle through the next 3 slides and back again. All of these are showing scientific papers from people who are studying earthquakes, from people who are studying glaciers, from people who are studying underground water storage, all using data from the satellite and all finding that data useful and relevant when they're on the ground. And no flat earther looks at these papers at all to try and adapt their model to it. It's just ignored like it doesn't exist. Completely ignored. Now, I know my time's up, but very much so. My last basic point in this little section is that everything supports a globe. Everything ties in nicely, and no model at all can even tie 2 things together for any other shape than a globe.
Finish your sentence.
No, that was it. Yeah, that was it. I'm done.
Okay, thank you very much, guys. Now then, we are ready for the 10-minute rebuttals, and I should probably remind you to submit your questions to the community tab. There are 4 currently, and so please submit more, and most of these are for Chirag, but probably it would be nice to have some for Catz as well. Now, I'll set the timer now.
If we can put up I'll just continue on from where I was at last.
Okay.
Yeah, back to the slides, Chirag, is it?
If you don't mind.
Yeah, not at all.
Okay. Are you ready?
Yeah, whenever they pop up, that's fine.
Okay, so from number 10, Chirag,
Yeah, I think it's where I had the collection of equations.
we can set up a system of equations.
Yeah, please.
Yeah.
That's right. Yeah.
There we are.
Okay.
Okay, back
So
on the
10
screen for you whenever you're ready.
Okay. So just to kind of continue.
10 minutes starting. 3, 2, 1, go.
Okay. So, this is a model. Once we, let's say our desire in this case was to model that pixel with the number 5, we cannot just set up one equation to get that number because we're dealing with many, many variables here. So in this case, we would need a system of equations. They're not linear. I'm just using this as an example. And so this is a model. This collection of equations, would be able to function as a model. And then we would be able to solve for particular unknowns if we have a sufficient enough equations. And so, and a sufficient enough things that are known or estimated or assumed, with some quality. So if we can go to the next slide, I want people to understand the actual definition of a model are mathematical relationships. That holds for financial models. That holds for, modeling images. That holds for modeling, seismic waves, everything. And so the quality of this model will depend on the integrity and quality of the measurements, observations, or assumptions, which are baked into those individual equations. And then the number of these measurements and observations are also very, very crucial. Let's say these were linear equations, then there's a theorem in linear algebra that says you need a minimum of the number of unknowns requires that number of independent equations, linearly independent equations. And so if this was a linear system, and so there are rules, to make sure that you come up with a unique solution. And so, these are the things that make a model good, robust, and then likely to be able to predict things going forward. So if we can go to the next slide. I want people to understand a model, no matter what anybody says, Catz or myself, is a system of equations. That's what it is, fundamentally. And we haven't seen any of that really from either side. That's going to be my main point. So what ballers do, whether they're doing this or not, I think they do, is they fix the Earth ESG, the Earth surface geometry, and then they let the other variables fill in the blanks. And so this is what we've seen. They sort of let the atmosphere kind of fix everything and all that kind of stuff. So this is what I call rigging the model, and I don't recommend flat earthers do this as well. So if we can go to the next slide. That's just a quick observation. That's what we see, especially when it comes to very, very complicated modeling like images. This is not what people do. If they're not confident that variable is what it is, then they let it free. And so we're asking all of us, I would say fundamentally, and even the ballers would probably want this for us if we were to model things. We're supposed to let that variable be free, and then find out all the other parameters and pin those down. So life is short, to me, would motivate a baller to do this, that he has proven that bottom-up obstruction across flat surfaces is definitely possible. Not even really in that much of sort of extreme conditions. I've done in my own demonstration in my hallway, and this is just intuitively obvious that this would occur even without a distortionary channel. So highly recommend people search Life is Short, a concept for vision on YouTube. Fundamentally, the take-home message is that taller objects always have a visual preference. You will never get a ball earther to concede that, but it's obvious. The black swan also shows that distant objects cannot also be obstructed bottom up. And so we have an explanation for images across a flat plane showing obstruction and not. And so there's more than enough reason to let that variable be free and pin down other ones. So also, don't assume it's flat either. If you're a flat earther wanting to do modeling the proper way, don't assume that either. So if we can go to the next one.
Okay.
So this is what is modeling. When somebody tells me they have a model, I know that they've gone through these steps. If they are a credible person doing modeling, they've conducted observations, they've limited the variables because we cannot encapsulate millions or infinite. So not too much. Like I said, there are rules in linear algebra, for example, that require a minimum number. You have to set up equations, you plug in known values, you generate enough equations to solve for the unknowns, then you solve for the unknowns. And then with those, now you have the ability to make predictions and to validate your solution and go test that, in other environments and see that if it can give you correct results. And so Life is Short is the only person who's done this on both sides of the debate. I've not seen anything even close to this nowhere near the language that is needed to talk about having a bona fide model on the ball Earth or the flat Earth side. If we can go to the next slide.
Great.
Highly recommend people to look at his channel. You know, and he's gone through these exact steps precisely. And he also explored the option of whether his results come from a ball Earth. So I'm going to now go into, you know, 3 quick points. If we can go to the next slide, I'm just going to talk about my personal evidences. Again, we don't have proof, industry support, and then qualitative aspects, just more my commentary on the absurdity, I would say, of a lot of the debate. So this is my evidence from a physics perspective. There's no noticeable Earth movement. That's just self-evident. There's no need to prove it. It's just obvious. And to me, for all the images, life is short, plus the black swan and other black swans show that, you know, all images can make sense across a flat plane. Also long distance tests, lasers, mirror tests, etc. There's a countless number online. And just a thought experiment, if 500 people put a spirit level on a major body of water, our position as flat earthers is that they would connect via a straight line, which to me is just intuitively obvious. I don't see any reason why that would not be the case. Ballers have to believe that a curve would get fitted through 500 spirit levels, you know, placed across, you know, a large body of water. And so to me, that just is nonsensical. We can go to the next slide. Those are my evidences from a sort of physics perspective. We can dive into those more. From an industry perspective, you know, I was an engineer. I worked as a seismic engineer for a few years at Schlumberger. We do not account for Earth curve in the statics phase, which is placing the true position of those geophones, recording the seismic wave, or the migration phase. And so I would love to see, you know, Catz or Tony or whoever show me where a person who's developing a ray propagator to tell me where that they take that into account. And the size of these surveys would demand that. Absolutely. 25 miles by 25 miles by 15,000 feet is appreciable. I got stories from Rumpus and Fight the Flat Earth that it's negligible. That's preposterous. You know, the only explanation is that the Earth is indeed flat. I've had conversations with pilots that I know personally, and they do not have any support in any of their training that they've been told that the Earth is a spinning ball. There's an interview on my channel from Casey Josh. He's going to pilots directly, confirming this as well. And I know people, and I used to work for a directional drilling company, and they do not account for Earth curve and tool design. So that's not as big of a survey, for example, reach as the seismic engineering, but, you know, 2 to 3 miles in the lateral, there's no accounting for Earth curve. So if we can go to the last slide.
Okay.
This is the qualitative aspect, and I think is probably the most important for me at this point, just because of what I've seen. The Bible obviously supports a flat stationary Earth. Even ball earthers have come forward and said this. So I don't understand why ball Earth atheists would not want to destroy the Bible. You know, if it's a false book with this much, you know, false information about the geometry of the Earth, the Bible should be destroyed, you know, worldwide. If we are indeed on a spinning globe, I don't understand the lack of fervor to make that happen. That doesn't make sense when a large group of people claim to have the truth. The existence of the debate itself is evidence of a flat Earth. There's a lot of military on both sides. That's suspicious to me. The lack of rigor in the debate on both sides, to me, is also evidence of a flat Earth. Because the side that should be truthful and having more resources should be more inclined to rigor, and we don't see that. Ancients have depicted a flat stationary Earth. The modern day proofs that we're getting are stories, images, pictures, like just non-unique tests like sticks in the ground, angles to Polaris, stories, you know, all that kind of stuff. There's no detail, no rigor in any of this. Once we do get close to the details, people say they're not important. So that's suspicious to me. I'll give up the rest of my time. Thank you.
Okay, thank you very much. Now, as for the rebuttals, we have Mr. Catz next. Are you ready?
I am. If we can have slide 23 on the screen, please, then I'll be ready.
Okay, you have 10 minutes starting 3, 2, 1, go.
Thanks. Right, I'm gonna. There's 3 or 4 points I've picked up, and I'm going to try and address all of them there, Chirag. But you know, obviously, let me know in the back and forth if I don't. First of all, you mentioned that actually the Bible. You know, should the Bible be destroyed if the Earth is not flat? Well, I think even within the Christian community, you've got a big split between flat earthers and non-flat earthers. So, you know, I think that's something really you need to think about. Like, why are you holding the word of the Bible literally when there are Christians out there that don't have to? Because it seems to be at the detriment to your understanding or your appreciation of science. Slide 23, one of the comments you made was that, you know, the Earth, like current science tends to fix the geometry of the Earth. We fix it, and then we try and fill in the blanks to surround it. Well, that's not true. What we do and what the heliocentric model does, which has ruled out other shapes of the Earth, and that's why we're talking about models, because all these tests rule out other shapes of the Earth. What we do is we see things, and then we test them against the idea, you know, does this debunk what we already know, or does it support it? Now, here's an example. This fella is a guy called, and I'm going to pronounce this wrong. I always pronounce it wrong. I'm just going to call him Iotmos. I know that's wrong. He was a physicist doing some experiments. You can see that he was doing some experiments on a torsion bar, etc. Not quite the Cavendish experiment. But it doesn't matter because it wasn't working for him. He was sailing across the ocean, and every time he stopped moving, he was getting different results from when he was moving, and it started to annoy him. And that gave rise to something called the Iotmos effect. Now, what I'm going to tell you now would be assuming a globe, and then we test it, okay? So the Iotmos effect says this. If we go to the next slide, please, slide 24.
Okay.
The Iotmos effect says that there's a balance between two forces on the Earth. We have the gravitational force pulling objects down to the Earth, that gravitational acceleration. We see about 9.8 meters per second squared. But we also have the centrifugal force, which throws things up, tries to throw things off the Earth as we spin. Now, we know that I've drawn the red arrow bigger because the gravitational force is bigger than what's trying to throw things off the Earth. That's why things still fall. But, next slide, please. But if we are traveling west on a planet that's spinning west to east, if we are traveling west, what's actually happening is if the Earth is spinning west to east, as we say, then we're not actually traveling west. We're still traveling eastwards, but we're traveling eastwards at a slower velocity than the Earth. We get that relative movement. And that reduces our centrifugal force. It makes it smaller. So the difference between the gravitational pull and the centrifugal force gets bigger, and we should weigh more. And if we travel east, if you can just go to the next slide, please, we get the reverse. That centrifugal force, if we're traveling east relative to the ground, that centrifugal force gets bigger, and therefore we actually should weigh less. Now, that's not fixing geometry. That's allowing us to make a prediction. If our geometry is right, we make a prediction that traveling in one direction we weigh more, traveling in another direction we weigh less, and also the effect of that will be affected by the latitude we're at. Okay, next slide, please. Now, slide 27, Wolfie6020 has carried this experiment out for a YouTube video where in his plane, he's flown one direction, and as he's flown west, things registered a higher weight than when he flies east, okay? So a prediction has been made that verifies the shape of the Earth that couldn't be made on other models. And the whole point of this, remember, is that we rule out other models. So a stationary Earth is now kind of ruled out. But it's not just YouTubers doing this. I don't want you thinking that the people who are putting these videos forward are just making this stuff up themselves, you know, like a lot of flat earthers might do, you know, like we see people pouring salt in water and watching egg floats. That's not science. What you're about to see is science. If we go on to the next slide. Great. This is such a problem because the Earth is a globe and it's spinning, that geodesists now have to correct for this in a variety of situations, and the maths behind it is quite complicated. I'm not going to pretend to be able to explain what all of that means, I'll be honest, but what I do know is it tells us how much of this effect is going to happen depending on our latitude and the speed we're traveling at. If we go down to the next slide, please. We then see this employed in wider science. There are thousands of people, you know, you can type search for these papers yourselves. You're not going to find a shortage of them. Here's one about how people are trying to correct for the Iotmos effect. Sorry. If we go to the next slide, another paper from somebody else looking at how we correct for the Iotmos effect with the gravimeter, because the Iotmos effect is causing these people problems. It's not just something theoretical that Wolf is demonstrated on a plane. In the real scientific community out there for real people, it's causing problems and it needs to be corrected. If we go to the next slide, please. Oh, sorry. So when we talk about models, it's not about fixing geometry. It's about making predictions. And if those predictions support a model, great. If it doesn't, that model gets thrown. And that's why there is no flat Earth model, because it's been thrown by all the testing we've been doing. You mentioned bottom-up obstruction. How long have I got left, Heidi? Never mind. You mentioned bottom-up obstruction. So if we go to slide 23, 76, please.
Okay.
And you said...
I think I was muted. You have 4 minutes and 20 seconds.
Thanks. So slide 76, you mentioned that bottom-up obstruction has been accounted for and that fits both models. It doesn't fit both models at all whatsoever. Let me introduce you to diffraction, which is what Nathan Oakley fails to explain. When light passes through an aperture such as the eye, for example, the light will diffract and it will cause a diffraction pattern like we can see on the bottom left hand of that screen there. Now that diffraction pattern, we will get a diffraction pattern from every single point on an object we're looking at. So if I'm looking at a football and I'm looking at the top of the football and the bottom of a football, I will get a diffraction pattern on my eye coming from both of those points, from every single point, continually, from top to bottom. Now, if those, as we can see by the diagram on the top, if those diffraction patterns get too close because something's gone so far away, the angular size of it shrinks, then we can no longer resolve detail. If we go on to the next slide, we can use this slide here, the eye test, as an example of that. We look at the letters at the bottom; they are smaller. The diffraction patterns from the parts of the letters are closer together, and we lose that resolution. But this is perfectly well understood. Once the angular size between 2 points becomes less than 1.22 times the wavelength of light over the diameter of something, then things start to become unresolvable. If we go on to the next slide, it's perfectly understood science. It's called the Rayleigh criterion. On the next slide here, we've got a scientific paper about people correcting this in microscopy, using microscopes. Are we going to add people who make microscopes to the people who are lying about the shape of the Earth? Are we going to pretend that the people making microscopes and doing these studies don't understand resolution and the Rayleigh criterion? Are we going to pretend that a flat earther on YouTube who is shouting for super chats every 10 minutes does, but these guys don't? Let me tell you their misunderstanding. If we move on to the next slide, in reality, let's say we're looking at a lighthouse like this young fella is here. Hopefully he's on the screen. Is it lighthouse kind of screen?
Yeah.
Now, the light is entering our eye from the top of the lighthouse and the bottom of the lighthouse, and that blue dot represents the angle, right? And if that angle becomes less than 1.22 times the wavelength of light over the diameter of our eye, then we will lose the resolution. But we will lose that resolution top to bottom because it's that angle that's becoming smaller. What flat earthers like to tell you, if we go on to the next slide, please,
okay,
is they like to tell you that it's this angle here that I've represented with a red circle. This angle here that isn't even entering the eye. The light coming from there isn't even entering the eye. And people like Nathan Oakley will tell you that as that angle gets shorter, that's the reason things disappear bottom up. Now, what's more likely? Is it more likely that science and the thousands of scientific papers on resolution and angular resolution are correct and that Nathan Oakley is wrong? Or is it more likely that Nathan Oakley and Quantum Eraser and all the flat earthers that follow them somehow have come up with something which these thousands of scientists have failed to spot? What is more likely? Okay, and it's not the one I've just said.
1 minute.
So, thank you. So it's, ultimately it's perfectly understood why things disappear from the bottom up, and it is not due to resolution, and it's not due to things being close to the ground and just getting further away. To say it is just deliberate and willful ignorance of all the science that's out there. And it's amazing to me that we never actually see flat earthers taking on these scientific papers like the one I've shown you about the Rayleigh criterion and explaining to us what is wrong. But we all know, everybody watching knows why they don't do that. And that's because obviously it's all guff. If we go to slide 60, I've only got a minute left, haven't I? So I'm not going to finish the Black Swan
15
argument.
seconds.
Yeah. So I will give up because I'm not going to finish any other argument. But thanks for listening to me waffle on, Chirag.
Okay, very good. Now we are probably moving on to the back and forth, unless Creaky has something else planned.
No. I'm like I say, I'm keeping an eye on the side chat, and just sitting back and listening. So if you just want to move straight into the back and forth, as long as you're both happy to do that. If either of you need any of your slides during the back and forth, just give me about 5 seconds warning, shout out the number you want of the slide, and I'll pull it up for you as quickly as I can.
Okay, now that Catz just finished, shall we start the back and forth with Chirag?
Yeah, I guess if we can start with gravity, we'll go with that.
It's 3 minutes, and are you ready?
Yes, I will not need the 3.
Okay.
But, yeah.
Starting 3, 2, 1, go.
I guess we'll kind of go in sequence. Address the main thrust of the stuff Catz was talking about with models. And so I just want to make sure that you all are consistent and hold you guys to this. If you're prepared to then take measurements and expect accept that their differences spatially, geographically are related to gravity exclusively, then if there's ever a contradiction, I just want to make sure then that you're also willing to leave the ball Earth understanding. If they do not match your prediction, you can't double dip, right? I just want to make sure that if people do take weights, for example, and different parts, let's just say hypothetically, I don't have this information, but let's just say I'm just as a thought experiment, they do not follow your prediction, even one measurement, you would have to then be prepared to leave the ball Earth, correct? I'm done.
Right, sorry. So I got through. So the question.
Yeah, thank you very much.
Sorry.
Now I see Creaky just posted the link to the community tab for the questions. Just go there and leave your questions. We'll go with back and forth for a moment, and we'll be starting the questions in about 20
Yeah, can I just jump in for a second?
Yes.
A lot of people are asking in the side chat how they ask Mind of God a question, how they ask Catz a question. There's 2 ways of doing it. You can either super chat your question, and the super chatted questions will be given priority because they're super chats, or you can jump over to the community tab of the Agree to Disagree channel. I have shared the link a couple of times, and I'll continue to do so, and you can post your question there, and we'll get through as many of them as we possibly can.
Yes, exactly so. Catz, ready?
Yes.
Okay, 3 minutes starting. 3, 2, 1, go.
Okay, so Shrek, like I said before, please do interrupt if I've got your question wrong, though. I think your question was if if something come to light about gravity that didn't fit our model, etc., will we take that seriously? I assume, will we allow that for a change in the model? Well, that's how science grows. And that's the point I've made from the very beginning, isn't it? You do alter things and you do change things and eliminate certain ideas as new information comes in. But for now, all the information I'm getting, is supporting the globe Earth 1,000,000%. So if we can just go to slide 35, and I'll give you another example. Slide 35 here, what you're about to see come on screen is it on screen?
Not yet.
Okay, so
it is now.
Okay, this is the equation for a pendulum. The time period of a pendulum when swung at small amplitudes, and we see that little g there is the acceleration due to gravity. Now, you might not want to call that gravity, but it's the acceleration. It's 9.8 meters per second that we do see things accelerate towards the Earth. Now, the thing is, if the Earth model was correct, then again, this forces us to make another prediction. And that prediction is, if I take that pendulum and I move it around the globe to different latitudes, where, like I said before, because of that Eötvös effect, the perceived acceleration becomes less, and we should see that effect on a pendulum. And if we go on to slide 30, I'm going to rattle through these quite quick, but if we go on to slide 36.
Okay.
We can see here, this is something a subscriber mentioned me a while ago, actually, that, pendulum clocks actually don't work the same way at the poles as they do at the equator. And I found this nice little story starting on page 38. So slide 38, we can get that up, Creaky.
Yeah.
And it just tells us about one of the very first clocks that was taken from the Netherlands over to America, I think it was. And when it got to America, it wouldn't keep time. It just wouldn't keep time anymore. So then they brought it home because they thought it was broken, but suddenly when it was home, it was keeping time. And when we did the calculations, that pendulum clock, it fits perfectly with the idea and the calculations that the change in gravity because of that Eötvös effect and because of the latitude had affected the clock. Now, we get a lot further on that. Now, if we just go to slide 34, what we actually do now...
30 seconds.
Thank you. What we can actually do now is we can use gravimeters to measure what the difference in gravity is between the equator and the poles, and it's about 0.5%. And when we use that to a pendulum, and we apply that to a pendulum, we see that 0.5% expressed in the way even a pendulum swings. So when you ask me if something come to light that was against our model, well, show me something that is against our model, and I will absolutely, we will absolutely adapt, change, throw things out where necessary.
Time. Finish your sentence and then we'll go on.
But so far, nothing is against the model at all in the entirety of science.
Okay, thank you. Now, we'll go to you, Chirag, next.
Yeah, I guess. Yeah.
Sorry?
No, go ahead. Sorry.
So now, starting 3 minutes, 3, 2, 1, go.
I guess that's really my fundamental point, is that that's really not what's allowed when we're talking about unique solutions, which is what the Ball Earth claims to have, is that, an observation or a point that is outside of explanation in the Ball Earth does not mean now you get license to wiggle room and then just, throw things out and adapt. That's not what we're dealing with here when we're talking about rigorous modeling and mathematics, that it has to be thrown out. The understanding has to be built up from scratch. And so my point is that if you're using those points, which that's fair enough, you have your reasons to believe in the Ball Earth. You're obviously, that's your stance. And you're making, I believe, correlations at best. The only issue with that is then evidence that's contrary to that means that you have to start from the beginning. And so it doesn't mean that you adapt and change and just kind of say it's an anomaly and hand wave it away. And so I want anybody who's using various things as proof then, and exclusive proofs of the geometry of the Earth, then you are now forced to live and die by those. That was my only point. And, that's fine. I'm sure you can come up with a lot of different things that can be predicted on a Ball Earth. And none of them to me that I've seen have shown a unique solution to a curved Earth. But that's what I wanted to say. We can move on if we want to bottom-up obstruction. I feel like you basically proved it on your slides, that that drawing that you made, you're just missing a horizontal line. So that angle that's being made to the top of the tower to the bottom is not always the same. It can be, obviously, if the geometry sets it that way, but it's not. And a generalized understanding, a rigorous model would separate those two angles and then understand that they have very, very different viewing properties. And that's exactly what Life is Short presented in his work. And he did show that because of the height of various objects being away from a surface, then there's less likelihood of being confused by that surface. And so that's fundamentally what it is. Height always gives viewing preference. It does not matter what surface we're talking about. And that lack of concession from the Ball Earth side tells me we shouldn't really talk about optics, because that's obvious. It's not even like, I don't even know why this is even a question, why the Ball Earthers struggle to concede that point when it's just flat out obvious. We do not need Life is Short's concept of vision, which is like a 4-hour video, to prove that. He just goes into more
30
detail.
seconds.
He just goes into more detail and then goes the next step and uses that to make predictions. And so I don't understand that. I don't understand. I mean, I know why that's the case, but I'm curious why you're not willing to accept that height always, in a mathematical sense, gives visual preference. That's it.
Okay. Is it me?
Yeah, Catz, I don't know if you want to just rip straight in again.
Thank you very much. And then we go to Catz.
Yeah,
Are you ready, Mr. Catz?
Yeah. Well, okay. I showed you a paper.
Okay, 3, 2, 1, go.
I showed you a paper just a minute ago, and that paper, was clearly explaining the Rayleigh criterion. I'm not going to sit here and pretend that the resolution limits aren't perfectly understood. I'm not going to sit here and pretend that there aren't thousands and thousands of papers and studies out there. I'm not going to sit here and pretend that people that design microscopes and telescopes don't understand resolution. I'm not going to sit here and pretend that people that design cameras, don't understand resolution and resolution limits. It is perfectly understood, and it's all out there. Now, that diagram I drew, what was not, I mean, you're telling me it's wrong, but there's no scientific explanation why. I can talk you through the whole diffraction pattern. I can talk you through the whole way they overlap and how the principal maxima of one has to be above the first minimum of the other before we hit the resolution limit, and that the angle that occurs at, if something goes beyond that angular size, smaller than the angular size, we can't resolve them. I can talk you through it start to finish. But there's absolutely nothing in flat Earth that could come back and explain why things should vanish from the bottom up, because they just don't. So I don't know what to say other than I'm just not going to pretend that it's anything but fully understood. And until flat earthers are going out and looking at these papers and studies on the Rayleigh criterion, looking at how things like microscopes are designed, looking at how resolution is figured out, looking why electron microscopes have a better resolution than a light microscope, until people start going and doing that, it's not worth taking. I can't take that point seriously because it's just not true. Now, if we go to the black swan image, and this is a killer. Now, I've got that somewhere on here. How long have I got left, Heidi? How long have I got?
We have minute and 15 seconds.
So the black swan image is slide 68, if that can come up. Now,
yeah, okay.
If we are being told over and over and over and over and over again that as things disappear, then they vanish from the bottom up because of some sort of optical phenomena, then how can flat earthers have a double standard of claiming that the black swan image is proof of a flat earth? Because when we look at the one on the left, where we can see further, we can see right down to the bottom pretty much of that. So what's happened to the angular resolution limit there? That's perfectly understood by the rest of the world. What's happened there? Why are we not seeing that vanish from the bottom up? Is a better explanation not actually that things don't vanish from the bottom up due to this resolution, okay? And resolution and the Rayleigh criterion is perfectly well understood.
30 seconds.
In fact, things vanish from the bottom up, as we see on the right-hand side, because there is obstruction due to Earth curvature, and that is perfectly explained by all our understanding of light and waves and the way they travel, and diffraction patterns and the Rayleigh criterion and all the thousands of papers that are out there. So unless you can give me some science explaining why things should vanish from the bottom up, I can't take it seriously. And that's been done.
Okay.
Yeah, you had 2 seconds left. So that's perfect for that 3 minutes. Now, we've had two from both of you. Chirag, would you care to start your next 3 minutes?
Yes. So this is good. I would say this discussion.
Okay.
Yeah,
so your clock starting 3, 2, 1, go.
Okay. Yeah. I think basically through all these hangouts, I think we boiled down really what is the difference for me personally between a ball earther and a flat earther at the root of the optics. And so Catz's diagram, if it's possible to be brought up while I'm talking, where the person's viewing the lighthouse. I don't know what slide that is, but I'm not sure if I have access to his slides. But that image, that really depicts the crux of this this debate. At the very root granular mathematical level, is that their understanding is that that angle is the only thing that's necessary to describe the visibility of that lighthouse, and it is not. That is our position, my position. I'm sure other people who are into this would agree, is that the angle between that person's eye and the base and the top need to be delineated. It's not just a theta, it's a theta 1 and a theta 2. And if ballers refuse to do that, then yes, that mathematics that he's explaining cannot be applied to the top and bottom separately. They're always going to be applied in combination. And that is the mathematical flaw. That is incorrect modeling. That's why I talked about in my presentation about freeing the variables. You need to have those variables free in order to truly understand what's going on in a more generalized setting. And so if your objective is just to make sure the ball earth works, then yeah, you would eliminate those two thetas and make one, and then assume that the visibility of the top and the bottom will always be equal if the top is visible. That's not the case. It's been demonstrated many, many times. And again, Life is Short has put the math underpinning that using the concepts that Conspiracy Catz talked about. And so if you're not willing to separate that angle to the top and the bottom, then the name of this channel is very appropriate. We have to agree to disagree. We will not agree on anything about optics, black swan, nothing. We're just starting from a foundation of very, very two different mathematical understandings, and we can just agree to disagree. So I can leave the optics alone. I would say for anybody out there who is doing rigorous modeling of this, you absolutely need to differentiate those two angles. They can be the same in some constructed scenarios, but You know, a lot of times when we're talking about a human standing on a shore, something very, very far away, then the angle to the bottom is usually very, very tight. And then the angle to the top is, you know, plentiful. So that's the fundamental difference. It took some time for us to sort of know, you know, what is the real crux of it. And to me, then you're really talking to somebody who believes in something that, you know,
30 seconds.
That's their choice. It's a choice at that point. If they don't want to explore that option, that's up to them. A lot of us have, and we understand that objects do and can disappear bottom up across any surface, given certain conditions. That's it.
Okay, thank you very much. You had 12 seconds left. Creaky, have you set up the polls on the community tab?
I've not done polls tonight, to be honest with you. I think we'll just do one at the end, because we're already up to 32 questions in the community tab, and I think about 10 via super chat. So we're already quite full up of questions. So
yeah, okay. How many did you say 10 from Super Chats?
10 from Super Chats, and there's 32 currently in the community tab. So we've got quite a lot to get through. So we'll try and get through as many of them as we possibly can.
Okay. Then next is Mr. Catz. Are you ready?
Yeah.
Okay, 3, 2, 1, go.
Can you bring the lighthouse up again, please, Creaky? Lighthouse one. Now, I'm not actually going to use my 3 minutes. So what I'm going to do is I'm going to formulate a question, and if you're happy to answer the question, I'm just going to give you the remainder of my time, and then you can have your 3 minutes after that. Should I give that? If that sounds
let's do it. Yeah, we can tighten it up.
Okay. So, you said that there has to be a horizontal line splitting the top half of the lighthouse and the bottom half of the lighthouse into these angles, θ1 and θ2. Well, let's do that, and we can do that by halving the size of the lighthouse. And then, therefore, the angular side, you know, if the lighthouse was half as tall, then you've only got your θ2. Now, I don't understand.
Horizontal line from the person's eye out.
Okay.
Yeah.
Right. So let's say we have that horizontal line going across there. What I'm going to pass back to you in a second is I want to ask you to explain, using the science of resolution and the Rayleigh criteria and optics as we know it, why that would, even then, why would that make the lighthouse disappear bottom up? Because all of science, all of the studies on resolution and light and optics and physics that has been done for generations, involving thousands of scientists and all the thousands of papers, not one of them says that. So the fact that you are saying it, I would really like to know what your explanation for that is. So can you explain why having that line would make things disappear bottom up?
Yes, that's a good point. Let me know if I can go back.
Yeah, no, I'll give you my time now. I'll stop.
Yeah, so it's applying the same physics. I'm not changing the physics. I'm just applying it to two different viewing scenarios. So just a thought experiment for people to understand, if they haven't thought of this yet, is that if you look at something, for example, like a high-rise building being constructed, and you know that it's being planned and constructed, but you look out, hasn't even been, concrete hasn't been laid yet. But then they tell you, okay, the first floor has been done, but you look out, you still can't see it because it's too far away. Then they tell you, okay, the second floor has been done, and you look over and you're like, okay, still can't see it yet. But then they tell you the 35th floor has been completed, and you're like, okay, yeah, now I see that there's a high rise being built, let's say 5 miles away. And so that's the fundamental issue here, is that angle that is being formed to the base, that base still exists. That base is still real and physical across a flat Earth, but it's not visible due to that angular limitation, whatever you want to describe it, whatever the true math is to explain that. And I don't question what you're working on, because it sounds exactly like what Life is Short did in his work. So that's the fundamental difference, is that
30 seconds left of this bit.
Yeah, height always has viewing preference, always. Doesn't matter if we're talking about a curved Earth, slightly curved Earth, more curved Earth, or a flat plane. That's a fundamental principle that is explained by the equations that you presented.
Rag, you can go straight into your 3 minutes if you want to, pal.
Yeah. So that's really the question. It's like, I don't understand why ballers.
Clock starting now.
Okay, I do understand. I'm saying this rhetorically. True, sincere ballers out there should be willing, especially the math ones, to allow those two variables to be different. And then once a person does leave that door open as a possibility, that doesn't mean that the Earth is flat at all. That's not a flat Earth proof at all. All it does is it means that you need to explore other explanations when looking at various images. And so it's not simply Earth curve. that is the thing that is creating obstruction or curvy rays that's allowing things to be seen far distances. That's not the only explanation. And so life is short, coupled with the black swan, is certainly not flat Earth proof. It's very, very strong evidence that we can explain these images across a flat plane. And so free the variables. That's what we need to do. If we're talking about real modeling, real rigorous mathematics, hopefully there's a new wave of people to flush out a lot of the old ideas because they're horrible and non-rigorous, non-unique, non-mathematical. That's the kind of way that a person would pursue these kind of things when they're looking at things to decide the geometry of the Earth that we stand on. That's it.
Okay, thank you very much. Now, shall we go to Catz now for another 3 minutes and then go to the questions?
Yeah.
Okay. Catz, ready?
Yeah. Can we go to slide? Sorry.
Yeah. 3, 2, 1, go.
Can we go to slide 78, please?
Okay, on the screen.
Okay. Now, I don't know how to put this, but like I said before, I am not going to pretend that the maths that explain the Rayleigh criterion that is in all the scientific papers, that is testable, is wrong. Like without an explanation, without somebody telling me what is going on with the maths, your assertion that somehow we split it in two and it should still disappear from the bottom up and you're using the same physics, you are not using the same physics. I've got a very strong feeling that if I asked you to put a whiteboard up and explain the physics to me and show me the mathematical predictions it would make, you couldn't do it. Now, no flat earther out there has. No flat earther has gone to the level of actually using proper physics and proper maths to give a proper explanation for why things should vanish from the bottom up. What they've done is put things on the floor that looks very unlevel and lowered a camera to it and gone, oh, there you go. Okay, that's what we're dealing with. On the screen here, we have proper science, proper scientific papers showing proper scientific understanding of real physics. And flat earthers just claiming, oh, the maths is probably a bit wrong. And it's that I can't take seriously. I'll respect the people, but the idea is just absolutely nonsensical. Just to leave you with this, because I know I've not got long left. But if I go to slide 31, please, Creaky.
Great.
Now, people often talk about why should a gyroscope on a plane and the artificial horizon, why should it not drift off as you go over the curvature of the Earth? And we talk about correction mechanisms like pendulous vanes, etc., or electronic mechanisms. But what happens if we have a device that is sensitive enough that isn't corrected? Well, what you end up with is a gyrocompass. Now, a gyrocompass, I put on there on the screen, uses the rotation of the Earth, right? And how that changes at different latitudes on a globe Earth, only works on a globe Earth model to navigate. And they are so important. If you go to slide 32, these are the Merchant Shipping Naval Equipment Regulations 1993. Every single ship built after 1984, up to 16,000 tons, must by law have a gyrocompass installed because they work so well. If we go to slide 33, every single ship over 16,000 tons has to have one regardless of when it was built. So if these things don't work, if the science behind these doesn't work, and in the way that a globe Earth model will predict, if they are just broken and we don't understand the physics, then an awful lot of people in an awful lot of fields of science must be extremely stupid and not be able to see that what they are actually using and the data that they are getting is useless. How can they not? How can they be fooled so easily?
Finish your sentence.
Well, and that's essentially how can people, thousands, hundreds of thousands, millions of people, all be so stupid, yet a YouTube flat earther pouring water on a football has got it right. And that is the end of that.
Okay, thank you very much. Now, both had 4 sets of 3 minutes. Now we'll probably go to the questions. Creaky, you have the super chat.
So I've got the super chat questions. So we'll go straight through these because some of them are questions, some of them are not, but we'll acknowledge them and the questions will come up. So before the stream even started, Catz, somebody wants to know if you can upload the debate between you and Mr. Oakley that took place on Sleeping Warriors channel. So I don't know if you want to throw that up on the channel at some point, but that's the first one done. $2 super chat from Saif. Just saying to give the video a like. €2 from the Snark. Cat wins in round 3 by knockout. Gently's channel, £2. Much love for the like button. Andrew Stroll, $5. If the earth was flat, you would be able to see the mountains around Denver from the top of the Bank of America building in Dallas. Can you do that?
That's a question to me?
It's a question, Chirag, so if you want to address it, fire away.
I mean, in those statements, I just want people to hold to those. You know, if that's something that a person really believes is what they need to get to a unique solution, and we all have different criteria, I just want people to be consistent. Then if you do see that, you can't change the story. That's what we're seeing, you know, like, and the Black Swan is a great example of that. You know, people are like, we see blockage. Okay, we're like, yeah, it does look like there's a lot of obstruction in a lot of these images, but then we see one and now many that there's not. And we're like, oh, no, that's just because, you know, that we have surface rays of a K value of 1. And then, you know, they magically glide over the surface of the earth. So that's the part where I'm trying to, and I like this discussion. I'll be totally honest. Like we have to move towards what's called a unique solution, and the only way to do that is to understand what a unique solution is in mathematics. And so, if that person believes that is the case, and they're not able to see that, you know, let's just say in the times that they're going to view it, but then at some point when the atmospheric conditions change and they can, then I'm just going to hold. You have to be consistent, you know, especially if you're using something silly like that to prove the geometry of the Earth, because it's, like I said earlier, it's statistical, time varying, and nonlinear. So it's ripe for confusion.
Catz, have you got anything to add?
I forgot what the question was. Sorry.
If you were at the top of the mountains around Denver, hang on, I'm reading that really badly. If the Earth were flat, you'd be able to see the mountains around Denver from the top of the Bank of America building in Dallas. Can you do that?
I mean, I don't know how far those two place up, but there is, of course, you know, dispersion of light in the atmosphere, so you can't see forever and ever in the atmosphere. But that in itself is evidence for the globe, because instead of the horizon fading out with that dispersion, it's there, it's defined, it's clear. So I don't know the answer to that question because I don't know how far apart they are.
Here we are, straight down to the next one then. €50 from IMD Fox, and this one is for you, Chirag. EURL dispersal of radioactive contaminants from Chernobyl and the tsunami that rattled Fukushima fits with the globe model, but how does a closed container explain EURL and the contaminants? How do plate tectonics happen on a flat Earth?
Wow. I've not studied that tectonics. I don't know. I mean, I've done seismic imaging, which I can talk about, you know, if you know, another time or at the end of this, but no idea, way out of my realm. And I suspect by that very question, the person did not catch the first 10 minutes where I talked about modeling, because if that person did model those things on a curved Earth, and if they presented it using that framework that I presented, which is agreed by anybody in the world, that's how to do modeling, then they wouldn't have to ask me.
I think you are right. Actually, I do think that IMD Fox was later coming into the live stream. So we'll move on to the next one. $4.99 from Pete Bremble. This is more of a statement than a question. I think with overwhelming proof of the fact that the Earth is a globe, it blows his mind how stupid it is that people believe the Earth is flat.
I would say a lot of us know it now. So that's an awkward way to, you know, to go about life. But a lot of us, not just me, we know that it's flat and stationary because we know the architect of the flat Earth and we know why he did the deception. So he whispers in our ear quietly, but it's not a belief anymore. You know, we're trying to help you guys, girls, get on board with this reality. And the Bible's manifesting itself every single day. It's very, very clear.
Can I add something to that just very briefly? Is that okay?
Sure. Yeah, sure.
Chirag, what you said there is actually something more like, because I know you come from it from a religious point of view, and what you said there is, you know, why he's done the deception. Now, if your viewpoint is that the Earth is a globe, if your viewpoint is the Earth is flat, but God is making it look like a globe because of the way science presents it.
Yeah.
Well, that's the best I think I'm ever going to get out of somebody, the agreement that science proves, agrees to go. And I've said that to evolutionists, creationists, when I've debated those, if that's your argument, that's your argument, fair enough, and I respect that, because what you're not doing is trying to misrepresent the science. You're not saying that the science doesn't suggest a globe. And if your belief is that it's like a deception and it's a spiritual thing, fair play to you. I'm not going to argue with you with that.
Well, I want to word that differently. It's not that the science suggests it. It's that God has made certain observations work on multiple geometries, not just even a curved Earth, just a more curved or lesser curved and all that. So no, I don't want to say that the evidence is pointing towards a curved Earth, but I will take a step back from what you said, that yes, God has given everybody on the ball Earth side valid reasons, or else how could this kind of a thing be propagated? I don't think I would ever say that. I would say, even when people squish images, I make fun of it, but that's an evidence. It's not a unique proof of a curved Earth. Satellites, that's evidence potentially of a curved Earth. And I'm an electrical engineer. I got an offer from a satellite company that it didn't take, that sometimes I wish I did, because I might learn more about what they do. But yeah, these are things that there's evidence for a ball Earth. There's no doubt. We wouldn't come on any of these hangouts if that were not the case. And, we're seeking feedback from other people. But yes, if the Earth is indeed flat, I believe I know that it is. God would be the architect behind the deception. Absolutely.
Okay, straight on to the next one. It's our first super sticker, Catz, 149, and it's a salt cellar. Not sure if that means anything, but thank you anyway. Joshua Brackler, $2. Explain how a compass works on a flat Earth map.
I would say, if anybody wants a flat Earth map, just as a starting point for flight planning, go to skyvector.com. Wonderful site. That would be a place that I would start, for example, if I were to build a quote unquote flat Earth model. And, my pilot friends are familiar with that. It's open source. So, I would start with that. And then, on that, there will be obviously, navigational, orientations and all that kind of stuff. And then that would be a trustworthy place for me, because, person's moving. And, other people's lives are at stake and all that. So SkyVector is a good site for people to go to. I know people have used that to support the ball Earth, like Bob the Science Guy and MC Toon, but it's a two-dimensional surface that pilots fly over.
Right, straight on to the next one. Walter Bislin, 5. I'm going to have to learn what these various currencies are. CHF, 5 chuffs. Sounds cool. So the amount something vanishes from the bottom up depends on the amount that is visible above the horizon.
What was
I think
his point?
CHF is Swiss francs.
Thank you, Heidi. I guess you may know. Did you catch that, Chirag? Or do you want
my
me to
reading again? Sorry, Creaky.
Yeah, sure. So the amount something vanishes from the bottom up depends on the amount that is visible above the horizon.
In the context of no one would argue that. That's a correct statement. I think that the issue is that you don't know whether you're looking at the physical object fully, and we've seen that with mirages and all that kind of stuff. So that what he said is just kind of a sort of obvious statement. You have either the object or the horizon. Fair enough. That's not a big deal in any geometry. What we're noticing though is that with mirages, we're not sure what we're looking at. Are we actually looking at the physical bottom half of the object or a replica of it? And so, especially with those wind turbines, that's been greatly debated. And again, it's not a good position for a unique solution. It's not. It's a really, really bad place to look for a unique solution for the geometry of the Earth. Walter Bislin needs to free those variables, though. I think you guys get what I'm saying, but you have to do that. You have to understand, I'm not changing the mathematics. I'm applying it to two different angles and treating the top and bottom of an object optically separate. That's my only point. I'm not changing the Rayleigh thing or diffraction. That's not my expertise.
Okay, straight on to the next one from Brainless Steel NL, €10. And it's for you, Chirag. If with the lighthouse the angle needs to be split, in how many separate angles does it need to be? If you've got to split that, then you should not have to split it into millions of angles. Sorry. Did that make any sense? It didn't make a lot of sense to me, and I read it.
No, it's fine. It's at least two. You know, if you were concerned about the very top and the very bottom, I guess if there's a lot of width, you know, you may want to, you know, if there's one side that's more, you know, thicker than the other than the center, then yeah, you may need to go laterally, but at least two. You know, when we're governing the optical viewing ability of a device across any surface. That's my point. It's not just a flat Earth, and it's not a proof of flat Earth. It's a modeling thing. You know, that's what we would do.
£5 from Gary IOW. What is the relationship between max aperture and focal length? What are the implications? How do you calculate max aperture of a lens?
That's for me.
It's just it doesn't specify who is for Chirag, so
that sounds kind of easy. I'll give that one to Catz.
Thanks. I can't remember. I know when we were at school, when we were at school, before the lockdown, the highest we kind of go at A-level physics would be sort of like the lens equations, how lenses work, and we can calculate the focal length. But if you want to know so I know how to calculate the focal length of a lens. If we're looking at something distant, the light rays coming parallel, that's just the distance between the lens and where the lines converge. So when you say the max, there is a point at which, we're going to say it's so long since I've done it. I would have to look it up. I'm not going to sit here and pretend to have it to mind because I don't.
Good man. Okay, we'll move on to the next one.
Hope that helped.
From Walter Bislin again. The result when diving. What the hell? Shut up, Google. You're not helping. The result when dividing the angles into multiple angles is exactly the same. Maths proves that.
That's not true. I mean, we have to agree to disagree. I love the name of your channel more and more. We have to agree to disagree. That is not the case. I would highly recommend people explore that option. I don't know if there's very many really intuitive software packages to explore those things anyway. So it's just not a very good place to do tests. I mean, you could go and do hallway things like I've done. Still, they leave some ambiguity, but it'll motivate that possibility.
Next one is from Everybody Prefers Curves. £2. It's not a question, it's a statement. Creaky, loving that he can just sit there and chill. If that's what it looks like I'm doing, I must be doing a really good job, because you don't sweat when you're sitting here doing bugger all. But thank you, mate, anyway. B-Ball for Life, $5. To Mind of God again. Why won't you show us how your flat earth works instead of trying to point out where you think the ball earth doesn't work?
Yeah, and I think that debates like this will figure that out or not, if it's true or not. And so but the issue is that, and this is more I would say this talk was also criticizing the flat earthers, is that in order to have a model, you cannot shortcut or go, you can't avoid what I presented in the first 10 minutes. That is the way it is. If you do not present that in an academic place, you will be ridiculed. I'm talking about us as well, flat earthers. So that's the step. So if you were to ask me, for example, to use that understanding to then get the distance to the sun or moon phases and all that, I would apply that same methodology. The trouble I would have is getting data points, observations. I would be at the mercy of, equipment limitations and honestly, to some extent, creativity. I don't know how I would even start to do some of those things. So that will always probably be a fair criticism in the next 10 years, so yeah.
The next one, and again, I don't mean to offend anybody, but Ali B, who we all know and love, who is a flat earther, has paid just to tell us that we're all numpties for believing in the globe. So thank you, Ali B. You're a very generous individual. The next one is, and oh my God alive, why have people got such complicated names? Antiti, maybe, €2. YouTube told me to send money to you on Super Chat, so here you go. Another one then from B-Ball for Life, which is, how does a flat surface block an object, the sun, that is supposedly 3,000 miles above it?
Yeah, that's a good question. I was listening to Ranty's Hangout last night, and first thing we got to actually know what we're looking at. Is it the actual physical sun, the circumference, or the rays of it? And so identifying what is actually being obstructed, if it's the actual sun or not, is the first question. And then solar filters and all that will help. But fundamentally, let's not get too far ahead of ourselves, really, for all of us. If you accept that objects can be obstructed bottom up locally, then that doesn't answer the sun thing, but it gives a new understanding. It frees some variables up. So I'd highly recommend a person like B-Ball for Life to actually do that. But don't go to the more complicated stuff that's really, really far away. Start with stuff in your hallway, like I've done. And again, those aren't proofs. That's just, hey, maybe this does actually work this way. So he keeps telling me to do more tests. Why doesn't he go and show that an object can never be obstructed bottom up across a flat surface? Find a flat surface and record something and have it move away, and you'll see that your eye will always prefer the top than the bottom, always.
And just to be clear, I wasn't laughing at you then, Chirag. I was laughing at Ali B because he said for us to spend the super chat money on a tin of head polish and split it with Catz. So we may well do that, Ali B. Right, that's all the super chatted questions. So Heidi, do you want to start making your way through some of the community tab questions?
Go to the community tab.
If you sort it by newest first and then scroll to the bottom, that way then we can alternate newest and we'll both know where the other one is.
Yeah, I'll just take the. Shall I take the oldest one or the newest one?
The oldest one. So Tommy Gronwald, I think it was the first question.
Yeah, Tommy Gronwald, ask Mind of God, why is it so difficult to make a flat Earth model? Don't they have any measurements to any celestial objects?
Look at the people that are flat earthers. Not to be rude, but look at the people who are flat earthers. We don't have time. We don't have, PhDs, a lot of us and stuff. We have Nathan Thompson, who's yelling at kids in a school to become flat earthers. Life is Short is the only person that's contributed anything of meaningful substance to both sides of this debate. And that's just the beginning. And so that's not even proving anything necessarily in a concrete, absolute way. It's to motivate the possibility that objects are indeed obstructed bottom up across a flat surface. So I don't think we're going to get there. To be totally honest, I don't think we're going to get there. And that's not to be rude. That's an issue with myself. I don't have ideas on figuring out how far the sun is or what it is and what the moon does and all that kind of stuff. So it's, it would need time for sure, to develop that kind of a model. And so if it is indeed flat and stationary, God is gatekeeping this. If it's not flat and stationary, no one has to worry about the Bible being true because it's a joke. But I would highly recommend people to keep an open mind.
Right. Okay. And next up, we have Irish Dublin Girl. Why is there no unit of measurements on the map, probably referring to flat Earth map, either in miles or kilometers?
I'm not sure what map he's talking about.
I presume she's talking about the flat Earth map.
Like Sky Vector?
I would assume so.
Okay. I'm not, again, I can only talk about what I've had experience with that. All I've done is sat with Bob and MC2 and take me through something and then try to prove to me that 3 points on that don't obey 2D triangle geometry, but they're talking about a curved surface. So that was weird to me. And then I just mentioned it to my friend who's an amateur pilot about that site. And he said, yes, there are open source sites like that amateur pilots do use to successfully travel from point A to point B. And so, yeah, but nowhere did he tell me that in his flight planning that he's flying over a curved Earth. So that would be good. That's a good model for a flat plane.
Yeah, you mentioned the Sky Vector. There's someone, Cheshire Catz, saying Sky Vector is globe-based, not flat Earth. But as to the original question, I don't know which map Irish Dublin Girl was referring to.
I think they're probably just referring to the flat Earth map,
Yeah.
Heidi, because whenever you see a flat Earther using a what they consider to be a map of the flat Earth, there's never any dimensions on it. There's no scale shown in miles or kilometers or you know, or anything like that. So, but anyway,
shall we go to the next one?
Yeah.
Okay, Rory McAllister. Mind of God, why do we see the same stars in the lower half of South America and Australia simultaneously if we are on a disk?
I think you missed the first half of my presentation. I want people to know we're moving past that, whether you guys like it or not. That is not a way a person who claims to have a ball Earth model would go and talk to somebody else, because they would have already explored the other options when they produce that result. And so when somebody's doing that, what they're doing is they're outsourcing the work to me to explain a paradigm and geometry that I don't agree with and I don't care about, to be totally honest. I'm starting to lose interest in the flat Earth as well. So you're advertising your ignorance when you ask those kind of questions. So I don't think that people should do that. Even flat earthers don't do that. Don't go to a ball earther and say, why does this work on a flat Earth? And this is where the responsibility is indeed on us. We do have to have those answers. So I provided my support for a flat Earth, and they're not rigorous. They're not a proof yet.
Yeah, yes. And next up, we have Mark Swaby. For Mind of God, do you have any positive evidence for flat Earth, and where in the Bible does it say the Earth is flat?
Yeah, the positive evidence is, again, maybe they missed my little portion. So, you know, just the physics, the industry, you know, that I've worked with and talked to people who are doing things in the Earth or related to the Earth. And the Bible doesn't explicitly say that it's flat. Of course, like I said earlier, God would be behind the deception. So it's slightly encoded. You know, you don't have to believe that it is, but every single reference to the Earth in the Bible is stationary, in the very least. You know, Joshua, for example, is a good one that talks about the sun and the moon moving, and the Earth not being able to move to fulfill that verse. So if the Earth did move, the book of Joshua is false. That experience would be fictitious, and then that would call into question the Old Testament and then, to me, the New Testament. So if the Earth moves one iota, the Bible's garbage. Trash.
Okay. Then Luke Mitchell has a question for Catz.
Hey!
In an effort to steelman the flat Earth model, how many of your list of factors can you fit into one model? Example, a local sun with a moving lampshade shows day/night and accounts for a non-changing angular size. Can you get at least two? This is a bit weird sentence. Did you get anything of it?
I'm not sure what was. So how many? If I was trying to make a flat Earth model, how many things could I cram into it? Is that what he?
In an effort to steelman the FE model, how many of your list of factors can you fit into one model? Example, local sun with a moving lampshade shows day and night and accounts for a non-changing angular size. Can you get at least two? This is a really weird sentence.
I tell you what, I will go and look at the community tab. I'll read that question.
Yeah.
And then I'll tell you when I've read it, and I'll give it an answer.
Okay, that was 57 minutes ago by Luke Mitchell.
Right. Let me go and look.
Now, while Catz is looking up the question there, this is from Joe Howard, which could be for either one of you. Maybe since Catz is doing his research, perhaps this could go to you, Chirag.
What was that? Okay.
So, if you build a bridge without taking gravity into account, will it fall down?
Yes. Yes, it will. I don't understand what kind of question that is. That's very, very strange. Gravity are force vectors, or like whatever you call them, fictitious force vectors, placement vectors, geographically, in different positions. And so they allow essentially a curved Earth to function as a flat stationary Earth. So I don't understand why a person would be concerned about gravity more than the fact that they're building an object on a moving surface. And a curved moving surface. So I'm not sure why gravity would, let's say gravity was real. Of course, that would be something that would be needed potentially if you're on like the equator and then the force acting on one end is different than the other, let's just say, because it's a pair apparently. But no, the curvature and the movement would be of prime concern for anybody building anything on a curved Earth.
I think I found Luke's question.
Did you find it?
I did. I think what he's basically asking is, if I was to play devil's advocate and try and make a flat Earth model, how many things could I put in it without it obviously being wrong? Like how difficult would it be?
Oh.
And I'm just looking at all the things I stated at the beginning, and honestly, I don't even think I could put one thing in. Not even like the sun going around in circles on the top, without then asking, well, how does it stay suspended above the Earth? I don't think I could include one thing on a flat Earth model which would actually make sense. And obviously when I start including other things, it contradicts those other things. But I don't even think I could put one thing in. I'm just having a look. Not even daytime and nighttime, not even the simplest things. So it's a good question.
Okay,
yeah, squeeze out a daytime for us, man. You could, please, man. What?
Well, if you want daytime, you've got to have the sun in the sky.
Yeah.
You've got to have the sun in the sky. So what's keeping the sun in the sky? If it's a flat Earth, it's got to be small and local.
That's a good question. If that's your biggest concern from the get-go, then fair enough. So okay.
Okay. Thank you, gentlemen. Creaky, how much time do we have?
2 minutes.
2 minutes.
So what I was going to say, I'll just jump in very quickly.
Yeah,
obviously, now we're never going to get through the rest of these questions before the stream finishes. But I know that Catz will, and I'm sure that Chirag will also. Well, I shouldn't say I'm sure, I shouldn't assume, but if you wouldn't mind, Chirag, if you could have a look through the community tab after the event, and if you feel the desire to answer any of the questions that have been addressed towards you, then if you could do that, that would be a big help, because we do try to. Catz is he's looking as if he's fading away from hunger, so we do try to keep our times. People are still sending in super chats, so I'll just very, very quickly address the couple of super chats that have come in, because one of them did have a question. No, 2 left thumbs. Neither of your super chats have a question attached to them, I'm afraid. But thank you for the 2 super chats. One was £20, one was £1. The last super chat question: the spherical model was produced and refined over 2,000 years. The flat, non-model Earth is still sputtering after mere decades. That's more of a statement than a question, in my opinion.
Right.
B-Ball for Life, $2. Do you agree that the stellar parallax is possible?
Yeah, I had to look up what that term is. Again, B-Ball for Life coming with just a irrelevant question. Sure. Can things be understood that are far away in their position and understanding their motion? Yeah, that's not beyond our understanding. But if somebody tells me, for example, the angles to Polaris are doing something of unique worth to this debate, I'm going to ask, how are you measuring that? How are you ensuring that that angle is what it is, and that type of thing? And so we get crickets when we ask those.
Well,
if I may pop in, there's someone in the chat asking, where is the vote?
We will. I was just about to say, because I am the world's most professional and organized live streamer, I've still not done it. But as soon as I click the end stream button, it'll be number 1 on my list of priorities. I will post the poll as soon as the stream is over, so you can vote. You can vote straight away then. So Thank you very much indeed. I don't need to thank Catz. He's here all the time anyway. We can't get rid of him. But thank you to Chirag. Thank you for keeping in the spirit to which this channel was intended. It's been a pleasure to have you. Maybe if a lot of the other flat earthers we encounter were a bit more like you, then well, no, actually, I wouldn't have anything to make videos about then, so they can keep it up. But no, thank you, mate. I really mean it. It's been a pleasure.
I'd like to add to that as well, actually, because when I'd never spoken to Chirag before we emailed, and from the very start, I was the idea was to make it clear that this isn't going to be like going on Nathan's show or Ranty's show where people just scream and shout over each other. It was going to be productive, and we wanted to set an example. And I get competitive when I debate and enthusiastic, but I think we've shown how a flat earth debate can be, and hopefully, Chirag, if you've ever want to come back and debate something, or you've got a flat earth friend or anybody who wants to debate hopefully you've had a positive experience and you can say, I know where you'll get a fair crack of the whip, and that if you send them here, they'll get equal time at least, but thank you for being part of that.
Dude, I applaud the format with every ounce of my being. It's even if we're, again, agree to disagree, at least people can be more encouraged of their position, whatever that position is. I think it's great. So thanks for having me.
No, thank you for coming.
Sorry, I zoned out then. Yeah, I was trying to do something while I should have been concentrating, and I'm useless at doing that. I'm not a woman, so I can't do two things at the same time. I can barely chew chewing gum and walk without falling over. So thank you very much to everybody. Thank you to Chirag again. Thank you to Mr. Conspiracy Cat. And of course, thank you to Heidi for doing a stellar job of moderating. And
well, thank you very much.
No, it's been an absolute pleasure.
Glad you had me.
Yeah, we will most definitely be calling on your services again the next time Catz gets called upon to debate somebody. So,
or gets cold feet.
Or gets cold feet, yeah. Or gets held up in work, or gets too hungry and he has to duck out early to eat his lunch. Right, thanks very much to everybody. We will see you next Wednesday for another debate. Take care.
Bye-bye.
Bye-bye.